Welcome to my YouTube channel whose name is Knowledge Entertainment. And as I have promised, after set theory, now we are moving towards the next chapter, that is relations and functions. So one thing is to be noted, that before moving on to the relations and functions, there is one more concept in set theory, and that is Cartesian product of two sets. Cartesian product of two sets. What is this? Let A and B be two sets. Let A and B be two sets. Then Cartesian product of A and B is denoted as A cross B and is defined as A cross B is also a set containing ordered pairs AB, where the first member A is coming from the first set A and the second member B is coming from the second set B. For example, let A be the set containing three members ABC, and let B be a set containing two members 1 and 2. Now, if we will write A cross B, what type of elements will be there? These will be the all ordered pairs possible, whose first entry is coming from the set A and second entry is coming from the set B. That means it will consist of elements A from here, 1 from there, A from here, 2 from there, B from here and 1 from there, B from here and 2 from there, C from here and 1 from there, C from here and 2 from there. So these 6 will be the members of the set A cross B. One thing not to be confused, that the ordered pair A1 is not same as the ordered pair 1A, because when you write B cross A, then members will be 1A, 1B, 1C, 2A, 2B and 2C. Here 1A and A1, they are not same. A2 and 2A, they are not same. They are different elements. That means A cross B need not be equal to B cross A, because their elements may be different. One thing is there, if A and B are the same sets, then A cross B and B cross A will become same, because you will have A cross A here, here also you will have A cross A. Now, another thing, I am writing the set here. This is your A, this is your B, this is your A cross B and B cross A. What is the power set of A cross B now? We know that power set of a set means the collection of all the subsets of that set, that particular set. Here the particular set is A cross B. So when we will write P A cross B, that means power set of A cross B, it will mean the set of all subsets of A cross B. And how many subsets of A cross B will be there? The set A cross B has 6 elements, and we know that if a set has n elements, then the number of elements in power set of A is 2 raised to the power n. So here the number of elements in this set will be 2 raised to the power 6, that means 64. So it will be a set with collection of 64 elements, which I am not going to write here because it will take too much time. Now I move on to the definition of a relation, what a relation is. So I'll start with let A and B be two sets, let A, B be two sets, then a relation from A to B, is a subset of A cross B. So any of these 64 members of power set of A cross B is a relation from A to B. So we will take anyone. For example, if I write 1A 2B, then it is a relation from A to B. If I write 1B 2A 3A, it is again a relation from A to B. And we will write in general, the relation will define and will denote it by R, capital letter R. So I am writing here R to denote a relation. Now, another thing, for example, let us take only one example. I am considering this one. So this is a relation. Here, under this relation, the member 1B is an element of R. 1B is an element of this relation R. We also say that 1 is related to B under this relation. Generally, we write 1RB to write 1 is related to B. So 1RB means 1 is related to B. To be more clear, if 1 is related to B, it is not necessary that B is also related to 1, because 1B is a member of R does never mean that B1 is also a member of R. So it may not be there. If 1B is there, B1 may not be there in the relation. So 1RB means 1 is related to B. In some books, we write it as 1 tilde B. This symbol we call it as tilde. Tilde is the name of this syllabus. This symbol. Normally, this is your alpha, this is your beta, this is your gamma, and so on. Similarly, this is also a symbol, and its name is tilde. So we write 1 tilde B. 1 tilde B again means that 1 is related to B under some particular relation that is given to us. Now, we will be more concentrated on a relation from a set A to the same set A. So let we be more precise. I am taking both the sets same. Let A be any set. So take A to be any set. I am taking A as the set 1, 2, 3. Now, what is the relation on R? A relation on R means, or relation on A means a relation from the set A to the same set B. Relation on A means a relation from the set A to the set A. That means here we are taking set B and set A as the same sets. Now, consider some of the relation. Let us take R to be a relation containing elements 1, 2, 1, 3, 2, 3, 2, 1. Let these be some members of a particular relation R. So in this relation, 1 is related to 2, 1 is related to 3, 2 is related to 3, and 2 is related to 1. Note that 1 is not related to 3. Sorry, 1 is not related to 1 in this relation. Similarly, 2 is not related to 2 in this relation. 3 is not related to any of the members. Say 1. 3 is not related to 1 because 3, 1 is not a member of R. So this is the general definition of a relation. Now there are types of relations. First of those is a reflexive relation. So we define the first among them, that is reflexive relation. So let A be any set. Let A be any set. Let R be a relation on A, and relation on A means relation from the set A to the same set A. So let R be a relation on A, then R is said to be reflexive if A is related to A for every member A belonging to the set A. That means, suppose A is your set containing elements X, Y, Z, W, U, V. Let this be the set A. Now, a relation R will be reflexive if every element of the set A is related to itself. That means X must be there in the relation, Y must also be there, Z must also be there, W may also be there, must also be there, U must also be there, V must also be there. There may be some more elements in the relation R, but these elements must be. If even one of the elements, these 6 elements, if even one of these 6 elements is missing, then the relation will not be reflexive. It is clear, I think, that a relation is reflexive if every member of the set A is related to itself. If even one of the element of A is not related to itself, then the relation will not be reflexive. That is the first type of relations. And now move on to the second definition, that is symmetric relation. Symmetric relation. Symmetric relation. So again we start from there. Let A be any set. Let A be any set, and let A be R be a relation on the set A, on the set A, then R is symmetric if and only if for every A related to B, for every A related to B, we must have B also related to the member A. That means if 1, 2 is there in the relation, then 2, 1 must also be there. If U, W is there, then W, U must also be there. If A, X is there in the relation, then X, A must also be there in the relation. So look at the example. Suppose A is the set that is 1, 2 and 3. So consider this relation R. Let this be the relation 1, 1, 1, 2, 2, 1, 1, 3. Let us discuss whether this relation is symmetric or not. As per the definition of symmetric relation, for every member A related to B, B must also be related to A. So we start with the first member. 1 is related to 1. So this one must also be related to this one, and the same member will work. For the second one, this 1 is related to 2. As we want the relation to be symmetric, 2 must also be related to 1, and that is here. And this is vice versa. Vice versa means that is 2 is related to 1, then 1 must also be related to 2, and that is here. Now come on to here. then this 1 is related to 3. That means 3 must also be related to 1. But 3 is not related to 1 under this relation. So to make this relation symmetric, we must have one more member here, that is 3, 1. So now this relation is symmetric. Earlier it was not symmetric, but by adding one more element, this relation becomes a symmetric relation. Now we move on to the third type of the relations, that is transitive relation. Transitive relation. So what is a transitive relation now? We start again from the same starting place. Let A be any set and let R be a relation on the set A, then R is said to be transitive if for every A related to B and B related to C, we have A also related to C. That means if A is related to B and this B, the same element, is related to C, then A must also be related to C if the relation is to be transitive. And this should be for every two members of the relation, not for a particular member, two members or three members. It should happen for every two members of the relation. Now let us take one example to be more clear about this transitive relationship of a relation. So let R be a relation on a set A, which is 1 2, 2 1, 1 1, 1 3. I am taking this relation. Now, if A is related to B and B is related to C, then A must also be related to C directly. Let us see what is happening here. 1 is related to 2 and this 2 is related to 1. That means 1 is related to 2, 2 is related to 1 and 1 must also be related to 1, and that is here. It's true. This 2 is related to 1 and the same 1 is related to 1. So 2 must also be related to 1, and that is here. This 1 is related to 1 and this 1 is related to 3. So 1 must also be related to 3, and that is here. So it seems that it is transitive, but no, it is not transitive, because we will have to see otherwise as well. If I write this element first and this second, so what is going to happen now? 2 1 and 1 2. This 2 is related to 1 and the same 1 is related to 2. That means 2 2 must also be there, which is not present over here. That means this relation is not transitive. To make it transitive, we will have to add one more element, that is 2 2. And now this relation is transitive because for every two members of the type A is related to B and B is related to C, A is related to C is true now. Earlier it was not true, so it was not transitive. By adding one or more element, it becomes a transitive relation. Another important definition is here, the definition of equivalence relation. What equivalence relation is? Equivalence relation. Now, a relation which is reflexive, which is symmetric, as well as is transitive, is called an equivalence relation. So, a relation is equivalence relation if and only if it is reflexive, it is symmetric, and it is transitive also. So, if a relation satisfies all the three conditions of reflexivity, symmetricity, and transitivity, then it becomes an equivalence relation. Before ending this video, I am going to give you some exercises to check whether these relations are reflexive, symmetric, transitive or equivalence. So write down some of the examples, some of the questions. Let A be the set containing 3 elements 1, 2, 3. I am writing a relation R1 containing 1, 1, 1, 2, 2, 3, 2, 2. Second relation, I am going to write it here 1, 1, 2, 1, 2, 2, 3, 1, 3, 2. Third relation, I am writing here R3, that is 2, 2, 3, 3, 1, 1, 1, 3. Then I am writing another relation R4, 1, 1, 2, 2, 2, 3, 3, 2. I am going to write another relation R5, 1, 2, 2, 3, 1, 3. I am going to write another relation R6, 1, 2, 2, 3, 3, 1, 1, 3, 2, 2, 3, 3. Now, it is an exercise for you to check which of these relations is reflexive, which of these relations is symmetric, and which of these relations is transitive, and also check whether any of these relations is equivalence relation or not. So I am stopping the video here. I am thanking you once again for liking my videos, for sharing it with your friends and students, especially of class +1. And it is in general for everyone who is studying sets, relations and functions at any stage. So once again, thanks for subscribing my channel and sharing my videos. Thanks a lot.